Good afternoon. My name is Mr. Richard Christen. I'm going to talk about experiment 510. This again is the third experiment for the process control lab, so experiment 3, process control. And so if you're doing the 500 series experiments, whether you're doing 520 or 510, you will work with this apparatus. Now one thing that's going to be important for this experiment is that you will write, as part of your pre-lab worksheet, you will write a configuration file and use that file for this experiment. So you need to send that to me via email, the CFG file, and I will put it on this computer and set it up. So when you come in, your configuration file will be the starting point when you start working with this experiment. I encourage you to watch the video for the process dynamics for this experiment so you can see how the system is set up and how basically it all works. The only thing I'm going to focus on right now is data collection, because this is something that was not available for the process dynamics experiment, or not all of them. It was only made available right after spring break, and that is I have set up a macro in Excel to grab the data from the controller and bring it into Excel. So I'm going to demonstrate that feature right now. And there's a couple of very important points that you'll need to know to be able to operate this macro. So the file is on the desktop just like this. So when you come in, this file will already be active. And you want to fill out all your header information first before you start, because once you start data collection, you won't be able to click on cells and things like that, or you'll interrupt the collection of data for your macro, so it's going to be a problem for you. So once you input all of your important parameters and you're ready to start data collection, you press Control B, and that will activate the software WinWedge program, and it will start importing your data into the spreadsheet. In addition, it will plot these data in real time as well. So once you fine-tune the parameters of your controller, you can include a disturbance, and let me just do a disturbance here. So this is the disturbance variable here. So I induce the disturbance, and you'll see that the set point was at 20 centimeters of water. And now that I induce the disturbance, what you want the controller to do is then adjust the output so that it will get the level back to 20 centimeters. And so depending on how you have chosen your parameters for your controller, it may do that efficiently or not so efficiently. And so during the experiment, you'll want to fine-tune those parameters so that it works as efficiently as possible and at different operating levels. So when I remove the disturbance, the system will respond again, and then eventually it should come back to your original set point. Now, while I'm doing the disturbance, I don't need to worry about pausing data collection. But when I go to change the set point, which you'll want to operate the system at different set points, it's going to be absolutely imperative that you pause data collection. So to do that, you press Control P, and what I want to watch is this cursor. See how it goes from the plus sign to the hourglass. And I mean, as long as you see that, that means it's still collecting data. So now if you press Control P, and it stops, and it doesn't stop. See how it didn't stop? That means it's still collecting data, so you may have to press and hold it down for just a second to get it to stop. So now it's definitely stopped collecting data. The cursor is solid on the cross. Now to change the set point, you have to do it from the front panel. To change it, you first press this button here, and it says SP1, which that's what we want to change. You press the Enter key, and then there's my set point. Let's say I want to change it to 10 centimeters. I press and hold the down arrow key, and you got to be careful because it will really speed up on you. There we go. Now, this is going to be important. As soon as I press Enter, the system is going to respond. And I want to catch as much of that initial change as possible. So you want to be really prepared for that. So to restart data collection, you've got to press Control R, R for resume. And so what I'm going to do is put my one finger on the Control key here. And as soon as I press Enter, I'm going to then press R to restart data collection. The system resets, and it starts collecting data, and you'll start seeing it change to the new set point based on the instructions that I programmed into it. And provided that the instructions are proper, it will go to the new set point and it should be stable at that new set point. And depending on how I set the parameters, it may go to the new set point very quickly, or it may go very slowly. So it just depends. It depends on the system, and it also depends on the parameters. As you can see here by the controller output, it's gone to its maximum level of 20 milliamps. So really the system cannot respond any faster than it is right now. But at any rate, that's part of what you're going to evaluate when you look at these controllers, is how effectively is the system responding based on the PI and D parameters. Now, once you're done collecting your data set, you want to press Control E, E for end, and it will turn off the WinWedge program, and the data collection will stop. And so then you want to use the File Save As convention and give it a unique file name and save it on the desktop. Okay, so that's going to be very important. Now, like I said, keep in mind that your initial starting point for this system is going to be your controller configuration file. So you want to make sure you put a lot of effort into fine-tuning your control file and making sure that it works properly before you come to lab. Thank you very much.